This is the fourth video of connecting rod assembly. In this video, we will show you how to do an assembly of connecting rod. Disclaimer. This PPT has been prepared by referring many sources which include figures, diagrams from internet as well as from the prescribed textbooks and reference books. I do not claim any originality in preparing this video or PPT. This PPT or video is exclusively for purpose of education, not for any financial gains. I wholeheartedly thank all those who have directly or indirectly contributed to do this PPT and video. In this video, we will see how to do the connecting rod assembly. So first we need to open a assembly workbench. Once it assembly workbench open, automatically it will ask you to select the parts from where you are saved. Nothing but browse component from a documents or browse document from a folder. So there we need to go. There always you need to choose the first part. Always you need to choose first part where you are saved. Here the first part is ours connecting rod. So we'll take the first connecting rod. When it entered into the assembly workbench, please remember these things. When you reach the assembly workbench, so automatically it get fixed. So it should we should not use this automatic fix command. We need to make it right click on the future tree diagram and make it float. Once it float, if you use the left mouse button, it can draggable inside the workbench. Then you need to make the main part also assembled with the assembly workbench planes. So in the assembly, it has its own planes and the part has its own planes. We need to merge these two by using a mate command. So I will take front plane of the assembly mate with front plane of the connecting part. So here we'll get. Here you can choose front plane of the connecting rod. See, you can get an straight. Then give OK. Then the same way top plane and top plane of the assembly and the part. Give OK. Then right plane and right plane of the assembly and right plane of the part. Give OK. So then you will see the fully constrained. So don't use the F. Should not use the F symbol, nothing but fixed command. You need to give a assembly using a mate with respect to the planes of assembly and connecting rod. The next part is need to add the second part, insert component part, the next part. See, if you see now, if you don't know the next parts, then you should use the what do you call that diagram where you have the connecting rod. There in the list you will get which one is the second part we need to assemble. So always you should have that the drawing along with you. So in this one you can see the drawing. In this one the second part will be your next part to assemble. It will take some time to load. So once it gets load, see here you can make it rotate and zoom it. The second part will be bush, bronze bush. SolidWorks bush. Select the bush part, open. When it reaches here, see it can be movable anywhere where you want to place. So I place somewhere anywhere in the workbench. So then I will select the outer surface of the bush, mate with inner surface of the connecting rod pin hole. Give OK. Then you need to adjust the height. You can give plane of these two are made, or here these two we require a made. So I will take the hole, the oil hole of the bush and oil hole of the your connecting rod pin. So when these two are made each other, the height is also adjusted and rotational movement of this bush is also arrested. So that automatically it's showing right, it is constrained, fully constrained. Once it fully constrained, then only you need to go to next part. Then insert. The next part will be stud. So go to isometric. There you need to choose the stud. Okay. So here we will get the stud. Where you want to see. Now, how much? Now see here how much length you need to insert this one. So for that one, in the diagram you given the thread has 15 mm, means it can go only maximum is 15 mm. So you need to use this distance itself to constrain it. So what I will take the surface of this one and top surface of the connecting rod, and I will give a mate at surface of this one. Then, so instead of coincident, you need to give the distance mate. Here we need to enter values of 50. So we can rotate and you will see this, then this is the 50. Give OK. Now it should be inside the hole, right? Select the surface and surface of this one. See? But still it's not fully constrained. Why? It can able to rotate. See? It can able to rotate. So how to arrest this rotational movement? So further to what you need to do, you need to select the plane of this one. See, front plane of this mate with front plane of the main assembly. Now you could not give constraint of the coincident, you need to give only the parallel. So the whatever the rotational movement is also restricted. Then you can see it is fully constrained. Then once stud is done, you can mirror this one now itself, or at the end also you can mirror. To make assembly easier and faster, this one you can, instead of assemble now, you can do afterwards also. So you go to the next part. The next part is pin. So here we need to drill a hole and we need to make a pin. So for that one, we need to make a drilling of a hole. So in the features, in the assembly feature, this is assembly features, you have a options, right? Simple hole, extrude cut, hole wizard, hole series, any option you can use. Now I can use the extrude cut also, or I can use simple hole. It's left to us which one you wanted to use. All hole wizard. So I'll go with the simple hole. It will ask you to select the plane. I will select this face as a plane because it required a flat surface, and I will make it normal. Diameter is, what is the diameter of the hole? It is a 2.5. So diameter should be 2.5. Thickness, let it be this one, let it be 30 mm, because we are not bothering with respect to the height. Now we need to make a positioning of this one. So for that one you need to, using a left mouse button, you can drag it. Like this you can make a hole. Or like what we have the previous option we have, right? See, it's two hole. See, it can be visible from this end. It's not showing a shaded one. Here you can see the two hole. Or else you have a one more option, hole wizard. You suppress this one, go to hole features, go to hole wizard itself. Again, that is also the same case. It will ask the You can say simple drill hole, it will say 12 hole, diameter will get 2.5, depth let it be that much. Next, to go to the position, you need to select the face, make it normal, then you can select the arc, it will show the center. It will get the exact position location will get exactly at the required location. So you can get a free hole. This one is also one more option. Any option you can use. Now, once a hole is drilled, then you need to insert a pin. The next part is pin. So go to SolidWorks, insert, browse, select the pin. Open. Now, the pin needs to be inserted. So for that one, again go to mate, surface of the cylindrical surface, and any hole, any circle or inner surface face you can select. Give OK. See, the pin is inserted. Now we need to restrict the length, right? So for the length, you know the thickness length of the pin is 24 mm, and here we have a 20 mm. So you have 4 mm extra. So both the side you can give 2 mm. It is projected out. So I'll select this face and this face, and instead of coincident, I will maintain the distance of 2 mm. You okay. So it is 2 mm distance, it was restricted. See. Now again, this can be rotatable. Even though it rotate, it won't make any problem. So no need to constrain that one. So if it is a functional problems, then you need to constrain. Here you may ask why we constrain here. So here, if this pin hole, if you rotate, you could not able to insert the pin properly. That's why I constrained this one. Clear? Next part is after pin, you need to have a bearing brass. Insert the bearing brass, 2 pieces. Insert bearing brass, open, delete. So here, same way the inner surface of this one is constrained with the go to mate, or you need to select using a control, you need to select the 2 faces, then we need to go to mate, then it will be concentric, fine, and this face can be parallel with this. Flip it to rotate in other direction, and the only thing is you need to flip it, and it should be parallel, not the coincident, right? When the parallel is done, rotation is blocked, but it can be movable like this. So arrest that one. You need to select this face, inner surface of the brass, on top surface of the connecting rod. That will be coincident constraint. So once the 3 constraints are done, automatically it will be what do you call the block, but still it's showing some error with respect to the present mate. If we delete this one, it will, or we will delete the parallel one. Select this face, mate, this face, coincident constraint. Fine. Next, insert one more part. You can insert like this, or you can use a control button and select the work part which one you wanted to insert again, and use the control button, and you can drag it will make a copy there itself. Then you can rotate it. And use the right mouse button to rotate only that particular part. Then you can mate these two are parallel or coincident. Mate this face and the bearing on the face, and you can make this one and inverse of this one are concentric. Then you can make these two are connect each other or parallel each other. Left it will be. If it is the same diameter, same face, then definitely it will be connected each other. Next part is after the bearing process, we should have a distance space. So insert, rows, go to distance space, mate, circular face, circularity of this one, then bottom face of the distance space and bottom top face of the connecting rod. Okay. And these should be parallel. Make these two as coincident or parallel. If it automatically to coincident, nothing to worry, you can keep it as it is. The next part is after distance space cover. Insert component grows to cover. Now, cover you can make an assembly. The surface of this one, mate, concentric. Then these two faces should meet each other. Then two faces you can make parallel. Which one? Here itself. This one and these two. You can make as coincident or parallel. You okay? You can see distance cover is also it is constrained. These other components you can do mirror afterwards after complete assembly. Next part is washer, insert component, washer is missing. So again as part 2 is rotate. Again this one also need to rotate. Instead of button I will make it plain. Mate of these two, this face and this face meet each other. Then concentric of these two. Two circular face if you select automatically it took the concentric mate. And again it has not constant, it can be rotatable. Even though it rotate it won't do any problems in the function of that particular part. The next part is nut, insert the nut. Here also you can select directly the inner circular surface and the circular surface of the thing. If you use this arrow mark, it will reorient the part. And bottom face should but touch the washer top surface. Then you can see the hole. You can rotate it and you can get a hole visibility properly. You can keep that much visibility and you can mate these two arrows. This one and what do you call that? Nut one face and the cover one side face. You can make these two as parallel so that it will restrict the rotation of the nut so that you can easily insert the pin. Then the last one is split in, insert, grows, use split pin to assemble. Here you can use again the circular surface made with the hole circular surface. You meet each other. If you want to change the direction, you can change. In that, go to mate, edit feature. There you can change the direction. So it will come to this direction. Then you can have this one surface, and up to this tangent is not possible. Tap on to tangent, you need to select this face. Instead of this face, you can select this surface. So it has the tangent connection. So you can push a little bit. So when it's a tangent, it will take the curve. You can edit the two once again. Edit feature. And delete that mate. So these are all sometimes it won't work. Then you need to push this one manually using the left mouse button. Afterwards, you can make a split screen. Again, the same mate. So I will use the surface of this one. See, now it's to neatly. So there is this way you can do the assemblies. Okay. Or usually we will rotate the pin and we will meet. Right? Even though if you put like this also, nut will not able to rotate. Ultimately, the use of split pin is to the nut should not come out due to the vibration or some other functions. The next, all these parts need to be mirrored to this face. Go to mirror option near the linear component pattern. Below that you will get a mirror component. So first select the face, or you can select plane, to which plane you need to have a mirror. Then select the individual parts. The first one is stud. After stud, you require a pin. After pin, you require a distance piece. After distance piece, washer, then nut, then split pin. Okay. Sometime it will show errors. That time you need to do individually mirror. First three parts, then next three parts. This way you can complete the assembly. Afterwards you can make it in isometric view or diameter view with respect to your convenient, and you can have a save the complete assembly. This is connecting a rod. Thank you. For further details, you can contact me, Sandeep S, Department of Mechanical Engineering, Canada Engineering College, Controller, and my mail ID is sandeepmysore07@gmail.com, and my contact number is 9900092934. Any clarification or any information, you can contact me with respect to this video. Thank you once again.